Non-right-angled trigonometry summary. In non-right-angled trigonometry, we use the sine and cosine rules to find missing sides and angles of non-right-angled triangles. It's important that you know how to label your non-right-angled triangle. So if we label this triangle here with A, B, C, so we have angle A, angle B, and angle C, then the corresponding side to angle A would be this side, and the corresponding side to angle B would be this side, and the corresponding side to angle C would be this side. It's important that you recognise this when substituting numbers in for formulas. Here is a snip from the reference sheet. So on your reference sheet, under trigonometry, you have these different formulas given to you. So the first one up the top, these ones have to do with right-angled triangles. The rest of the formulas all have to do with non-right-angled triangles. The first one, this is the area of a non-right-angled triangle. This one is the sine rule, and you use the same formula if you're finding a missing side or a missing angle, but for a missing angle you would put the sine A on top. So it would be sine A over A equals sine B over B equals sine C over C. This one here is the cosine rule for finding a missing side. And lastly, this one here is the cosine rule, and it's to find an angle. So let's have a look at some examples. The first example we're going to have a look at is to find the area of a non-right-angled triangle. So the formula that we would use here from our formula sheet is going to be A equals a half AB sine C. Now, if we have a look at our triangle and we label our different angles, okay, we can see the sine C. Okay, so we need to have angle C. So that tells us that this here is going to be C, and then we might have A and B. It doesn't really matter which angles are A and B because we have both of those sides anyway. So our area will equal a half times A, which is 17, times B, which is 17, times sine, and the angle that we have is 70. And if you type that into your calculator, you will get 135.8 square centimetres. So when do we use the sine rule or the cosine rule? What information do we have to have on the non-right-angled triangle to use which rule? So the sine rule, to use the sine rule, you must have a corresponding side and angle. So if we have a look at this example here, see how I have this angle here, which corresponds to this side here, because we know that side C would be across from angle C, side B would be across from angle B, and side A would be across from angle A. So I actually have these two corresponding side and angle, and then I also have this one and this one corresponding. So that tells me that I'm using the sine rule. So we're going to use A over sine A equals B over sine B equals C over sine C. Because we're finding a missing side, we leave our sides on the top. So it's going to be A over sine A equals, and in this case, we've got C over sine C. So our A will be X over sine 28, which equals C, which is 17.5, over sine 73. Now we want X on its own, so we're going to multiply by sine 28 to both sides. So now we have X equals 17.5 times sine 28 over sine 73. If you type that into your calculator, you will get X equals 8.6 centimetres. Let's have a look at another example using the sine rule. So remembering that we need to have corresponding sides and angles. So first of all, we have this angle here, and it corresponds to this side here, because that's angle A, this is side A, that's angle C, this is side B, that's angle B, this is side B. And we also have this angle that we're trying to find, which corresponds with that side. So once again, we're using the sine rule, but this time we're trying to find an angle. So this time we're going to use sine C, because we're trying to find angle C, over side B equals, and what angle do we have? We have sine A over A. So sine C will equal sine theta over 21, which equals sine 43 over 31. Now this time we're trying to get theta on its own, so we will have sine theta equals 21 times sine 43 over 31. So all that I've done there is I've multiplied this by 21 and I've multiplied this by 21 so that we get sine theta on its own. And then whenever you're finding an angle, an unknown angle, you know that you're using the inverse of the trig ratio. So this will be theta equals inverse sine, which on your calculator you will hit shift sine, and then you will have 21 times sine 43 over 31. And theta will equal 27 degrees and 31 minutes. Let's now have a look at when we use the cosine rule. So to use the cosine rule, you will be given 2 side lengths and the included angle, or you will be given 3 side lengths. So in this first example, I've been given 2 side lengths here, and I've been given the included angle. So that means the angle that is between the 2 side lengths. And I'm trying to find another side. So as I said before, when you're using the cosine rule, to find a side, you use c squared equals a squared plus b squared minus 2ab cos c. So c will always be our missing side length. So this will be c, and then you can just make the other two sides can be A and B. So we will have x squared equals 9 squared plus 12 squared minus 2 times 9 times 12 times cos 103. Now we have x squared, so that means we're going to have to square root our answer at the end. I tend to enter it into the calculator with the square root sign. So I do the square root of 9 squared plus 12 squared minus 2 times 9 times 12 times cos 103. And if you enter that into your calculator, x will equal 16.5 millimeters. Let's have a look at another example using the cosine rule. So remember, if you are given two side lengths and the included angle, like the example before, or if you are given all three side lengths, you use the cosine rule. So for this one, we're given all three side lengths and we're trying to find an angle. So we're going to use the cosine rule, but we're going to use the cosine rule to find an angle, which is cos C equals A squared plus B squared minus C squared all over 2AB. So you can see that in our formula, cos C is our missing angle. So we're going to label our angle as C. So that means that 21 will be our side C. And then if you just label the other two sides, angles and sides, then you have the right numbers to put into your formula. So looking at the formula, we will have cos theta equals 27 squared plus 21 squared, plus 31 squared minus 21 squared. It's really important that you recognise that you're minusing off the side C squared. So you're minusing off the square of the side that is opposite the angle you're trying to find. And all of that is over 2 times 27 times 31. Now, remembering whenever we find an angle, we're looking at the inverse of the trig ratio. So theta will equal the inverse cos of 27 squared plus 31 squared minus 21 squared over 2 times 27 times 31. And if you enter that into your calculator, theta will equal 42 degrees. Okay, let's have a look at some HSC examples now. So here we are asked to find the area of triangle ABC correct to the nearest square metre. So if I have a look at the area formula that's on my formula sheet, it's A equals a half AB sine C. Now I haven't been given the angle for this triangle, so I'm going to have to find that first. And we know that to find an angle when we've been given all three sides, we use the cosine rule. So we're going to have cos theta equals A squared plus B squared minus C squared all over 2AB. Cos theta. So which angle am I going to find? Well, I can find any of the angles. Okay, so I'm going to find C. Okay, so if that's C, that means this will be side C, and then this will be side A, and this will be side B. So we're going to have 40 squared plus 50 squared minus 83 squared all over 2 times 40 times 50. And then theta will equal inverse cos 40 squared plus 50 squared minus 83 squared all over 2 times 40 times 50. Theta equals 134.2 degrees. So now that we've found an angle, we can use our formula A equals a half AB sine C. So we will have A equals a half times 40 times 50 times sine 134, which equals 719 square meters to the nearest meter. 719 square meters. So let's just have a look at one last example. So the diagram shows a triangle with sides length x centimeters, 11 centimeters and 13 centimeters and an angle of 80 degrees. Use the cosine rule to calculate the value of x correct to two significant figures. So we're going to use the cosine rule and we need our answer to two significant figures. So let's label our triangle. We can see here that we have a 80-degree angle, and if we have a look at the cosine rule, we can see that our missing side, it'd be helpful if that's C. So we'll put a C at x and a capital C at angle 80 degrees because that's going to be our angle that we use. And then we can just label the other ones A and B like so. So using our formula, C squared, well that's going to be x squared equals 11 squared plus 13 squared minus 2 times 11 times 13 times cos 80. And again, we have this x squared, so we know that we're going to have to take the square root, and you can just enter it straight into your calculator like this. And x will equal 15.5 centimetres. Now remember, our answer says two significant figures. So coming in from the left, my first two significant figures are 1 and 5, but we know that 5 will be rounded up to a 6. So it'll be 16 centimetres to two significant figures.